Okay, so once again, very good morning all. In the last lecture, we have started the problems based on the design of the shaft, that is type number 2. And based on that, three problems we have solved in the previous lecture, and one problem I have given for your homework. So many of students have solved that particular problem. They have sent that answers. Accordingly, I have given the reply. But still, many students are remaining, so still there is a chance to solve it, and you have to send that answers for my verifications. But before that, before proceeding to the next variety of the problem, just I will give the few explanation about the problem which is given for the homework. Some students are making the little bit mistakes, and due to that mistakes, they have followed same procedure whatever I have told. But due to some calculation part, there may be possibility of wrong calculation. So I will explain that particular few things which we have to take care, and then we will move to the next problem. Okay, so based on the design of the shafts, as already I have told, design of the shaft will be based on the shear stress and the angle of twist. That means the torsion formula is divided into the two different parts. One is based on the shear stress and another based on the angle of twist. And how to identify that, whether it is based on the shear stress or whether it is based on the angle of twist. So for that purpose, we need to read the statement carefully, and we have to check whether shear stress is given or angle of twist is given. If in the statement they have given only shear stress, that means we have to calculate the diameter by using the shear stress formula only. That is T upon J is equal to tau upon R. And in addition to that, if they are mentioning the angle of twist, that is theta value also, then same problem we have to solve to design the shaft, that is based on the angle of twist, and we have to use the second formula T upon J is equal to G theta by L. But whatever the two problems we have solved in the previous lecture, in that only value of the shear stress they have mentioned. And after solving that, the same problem I have given you for the exercise purpose. So this is the problem in front of you, which is given for the homework. By reading this particular statement, you have understood that here 65 Newton per mm square shear stress is given, and if you read the statement carefully up to the end, there is no any theta value, that is angle of twist is equal to 2 degree, 1.5 degree, 3 degree, like that they have not mentioned. That means need not required to use the second formula T upon J is equal to G theta by. Only single formula we have to use. And in addition to that, the last statement they have given T max is equal to 1.3 times T min. That means relation between maximum torque and the mean torque they have mentioned. Here the power is given and speed is given. So what is our first requirement? First of all, we have to calculate the mean torque. We have to mention the mean torque in the power formula because relation they have mentioned. If such relations it is not mentioned in the statement, I have told your T max is equal to T min is equal to capital T. Okay, so here the relation is mentioned, therefore we have to mention T min in the power formula and T max in the torsion formula. So I will give the steps only what we have to do. So first of all, P is equal to 2 pi N T min divided by 60. So here you have to put the values, that is power, it is given in kilowatt, you have to convert in watt. 2 pi is the constant parameter, N is given 100 rpm, T min value we have to calculate. So through this calculation you will get the T min value. Through this calculation you will get the T min value, and I think that T min value is 32.22 into 10 raised to 6 Newton mm. I have given already converted value Newton mm. Okay, and then you are having the T max relation. T max is equal to 1.3 into T min, and this T max value you will get as a 41.88 into 10 raised to 6 Newton mm. So up to this calculation is very simple. We have to use the power formula. From that we have to calculate the T min value, and that T min value we have to put in the relation which is mentioned in the statement, and you have to calculate the T max value. And now this T max value we have to use in the torsion formula for the diameter calculation. So we are having the formula, that is based on the shear stress, T max upon J is equal to tau upon R. Okay, so here what is important, let us see. 41.88 into 10 raised to 6 divided by, Hollow shaft is given, so pi by 32 in bracket do raised to 4 minus dr raised to 4 bracket complete is equal to tau is given 65 divided by do divided by 2. In addition to that, here they have mentioned internal diameter is 0.6 times external diameter. Means one relation you are having. What is that? Internal diameter di is equal to 0.6 into du. This relation we have to use for your further calculation. So what I will do, see here, where there is a possibility of mistake. 41.88 into 10 raised to 6 into 32 that I will take at the upper side. Pi by 32 मधले हे 32 मी काय घेतले वर घेतले divided by pi into square bracket. Try to use the square bracket. Du raised to 4 as it is minus what is the value of di? 0.6 into do. This is the total value. So what you do, you apply one bracket 0.6 into do small bracket complete and raised to 4 and then square bracket complete, which is equal to 65 into 2. This 2 I will also take at the numerator side and divided by do. What I have done, this step is very, very important. 0.6 into do and bracket raised to 4. Sometimes what students are doing, that is do raised to 4. Okay, 0.6 into do raised to 4 is equal to previous value. They are making the do raised to 4 only, but during the calculation they are not doing the 0.6 raised to 4. चुकून काय होते बघा, डी रेस टू 4 आपण काय करतो ह्याच्यातून कॉमन बाहेर काढतो. म्हणजे ह्याच्यातून बघा पाय इंटू डी रेस टू 4 जर मी ब्रॅकेट मधून बाहेर काढलं तर इथं राहिलं 1 मायनस 0.6. but you have to make the raised to 4 of 0.6 also, because total di value is equal to 0.6 into do. Don't make the raised to 4 of do term only. You have to make the raised to 4 for this 0.6 also. Therefore, try to use this square bracket for total value, and inside you have to use the small bracket 0.6 into do and the total bracket raised to 4. If you make only do raised to 4 and you take this, you will take this 0.6 as it is for further calculation, your answer will be wrong. So that care you have to take care here for your further calculation. Otherwise, the process is very simple. This do raised to 4 you have to take outside the bracket. This you have to take at the left side. You will take or you will get the term in terms of do cube, and then you will get the di value and you will get the do value. So what is your di value, or what value you will get first? I think do. What is the value of do? Can anybody tell me, those who have calculated?
155.63.
155.63. Yeah, man. And this value we have to put in the equation, that is di is equal to 0.6 into 155.63. Then what is the di value?
93.37.
93.37. Yeah. So these are your answers. Process is same, whatever we have followed for the problem number 1 and the problem number 2. But what care you have to take during the calculation if di value is given in terms of do value. So put this particular 0.6 into do inside the bracket and then make raised to 4 of the whole bracket. चुकून आपण फक्त do raised to 4 करतो, 0.6 raised to 4 करत नाही, आणि तेच कॅल्क्युलेशन आपण पुढे घेतो. Your answer will be wrong. Therefore, अशा ठिकाणी हा मोठा एक स्क्वेअर ब्रॅकेट वापरायचा आणि त्या स्क्वेअर ब्रॅकेट मध्ये असा एक स्मॉल ब्रॅकेट करायचा आणि त्याचा रेस टू 4. मग हा स्क्वेअर ब्रॅकेट केल्यामुळे आपल्याला लगेच कॅल्क्युलेशन मध्ये लक्षात येते की आपल्याला do रेस टू 4 पण करायचा आहे आणि 0.6 रेस टू पण करायचं आहे. आणि तुम्ही नुसतं असंच लिहिलं 0.6 into do raised to 4, आपण do raised to 4 करतो, but by mistake आपल्याला माहित असतं, but during calculation we are not making this 0.6 raised to 4 and we are taking as it is for the calculation. Okay, so this procedure we have to follow, and still there is a time up to the today evening. Those who have not solved, they have to go for this particular solutions and you have to send the answers to me for my verifications. Okay, so these are the 3 problems whatever we have solved. In that, the value of shear stress is mentioned, therefore we have solved the problem by using the shear stress concept only. Now, if angle of twist is mentioned in the statement, then how to solve it, that we will take now the next problem. Okay, so now this is the next problem in front of you. I will read the statement carefully, we will understand the statement, and then we will go for the solution. See, a hollow shaft, the shaft is given as a hollow shaft of diameter ratio 3 by 8. This diameter ratio means, always keep in mind, di upon do is equal to 3 by 8. It is not do upon di. This is wrong. Diameter ratio is always di upon do. So you have to take this particular term in your notebook. Notebook मध्ये कुठे तर वरच्या बाजूला लिहून घ्या. काही ठिकाणी इंटरनल डायमीटर इज इक्वल टू 0.6 टाइम्स डीओ असं दिलेलं असतं. इन सम स्टेटमेंट di upon do is equal to 1 by 2, like that they have clear cut they have mentioned, but only they are mentioning the word diameter ratio is 3 by 8. Then what is di upon do or do upon di? So always keep in mind diameter ratio is equal to di upon do. 3 by 8 it transmit 375 kilowatt power at 700 rpm. Just I will check it is 700 or 100. Sorry, it is 100. This is 100 rpm, not 700. It transmit at 100 rpm, full stop. The maximum torque being 20% greater than mean torque. Relation between maximum torque and mean torque it is given, and it is 20% greater than mean torque. Means whatever the first problem we have solved in the form of percentage, that same statement they have mentioned here. And the shear stress not to exceed 16 Newton per mm square. And twist in a length of 4 meter. Length of the shaft is given as a 4 meter and not to exceed 2 degree. How to check the problem? In the statement, if they are mentioning the length of shaft, angle of twist in a degree, then you have to clear that we have to solve that particular problem based on angle of twist also. And that twist is given 2 degree. Full stop. Calculate external diameter and internal diameter will satisfy above condition. What is the meaning of that? Because in this particular statement, shear stress is also given, angle of twist is also given. So we have to calculate the diameters by using the both concepts, and from that we have to consider the maximum value for the designing the shaft. Take capital G is equal to 0.85 into 10 raised to 5 Newton per mm square. So this is the statement where the shear stress is also mentioned and angle of twist is also mentioned. So we have to take both the conditions for the calculation, and at the end we have to compare both the diameters. Diameter obtained from shear stress value and diameter obtained from angle of twist value, and from both values which diameters are maximum. एकतर angle of twist चे maximum असतील किंवा shear stress चे maximum असतील. Those values are maximum that we have to consider for designing the shaft. Why? Because if your diameters are maximum, your area is increases, and if your area is increases, the shear stress induced in that particular shaft will get less. जेवढा तुमचा area maximum असेल तेवढं त्या shaftचे failure होण्याचे chances काय असतात? कमी असतात. Therefore, always we have to consider the maximum diameter for the designing the shaft. Okay, so first of all, I will write down all the given parameters. See, you also start writing simultaneously the given parameters. So first, di upon do is equal to 3 by 8. Then tell me the value. Di is equal to 3 by 8 means, what is 3 by 8?
0.375.
Take all the values, 3, 7, 5. Take all parameters into do. This is the relation. Okay. Then what they have given P 375 up to the Tmax calculation procedure is same. So you also start simultaneously along with me. 375 into 10 raised to 3 watt. N is given 100 rpm. Tau is given 60 Newton per mm square. length of shaft is given 4 meter is equal to 4000 mm. Theta is given in degree, we have to convert in radian. Please keep in mind, theta is given in degree, we cannot take this degree value in the calculation, you have to convert in radian. So 2 into pi by 180, दिलेल्या थीटाला जर पाय बाय 180 ने जर आपण मल्टिप्लाय केलं तर that you will get in the form of radian. So what is this value? 2 into pi by 180, tell me.
0.034.
0.034.
0.034. Send me all values, all the digits. 0.034. Only this much?
9.
90.
You not take what 90, only 9 you take. 0.0349 radian. 0.0349 radian. Then value of G, 0.85 into 10 raised to 5 Newton per mm square, and we have to calculate the external diameter and we have to calculate the internal diameter. So we have to solve the same problem by using the shear stress concept and by using the angle of twist concept. But before that, wherever the convergence are required, that is 3 by 8, we have to convert 0.375. The theta value is given in radian, sorry, degree. You have to convert it in radian. To convert the degree to radian, you have to multiply by pi by 180. Okay, radian to the radian जर degree मध्ये convert करायचं असेल तर what we have to do? डिग्रीचं रॅडियन मध्ये करण्यासाठी पाय बाय 180, तर रॅडियनचं
180 by
डिग्री मध्ये
pi.
करेक्ट, एक्झॅक्टली अपोजिट, दॅट यू हॅव टू कीप इन माइंड. डिग्री टू रॅडियन मल्टिप्लाय बाय पाय बाय 180, आणि जर तुमचा थीटा रॅडियन मध्ये आला असेल आणि त्याला जर डिग्री मध्ये कन्वर्ट करायचं असेल तर यू हॅव टू मल्टिप्लाय बाय 180 by pi. This is very important. Okay, so now another relation is also given. Tmax is equal to 20% greater than, that means 100 plus 20 divided by 100 into Tmin. Therefore, Tmax is equal to 1.2 times Tmin. times Tmin. Okay, up to this is the given parameters. Now follow our procedure, that is, first of all we have to use the power formula. P is equal to 2 pi n Tmin divided by 60. So P is equal to 375 into 10 raised to 3 is equal to 2 into pi into n 100 into Tmin divided by 60. So what will be the Tmin value? Do the calculation.
35.80 into 10 raised to 3.
Okay, 35.80 into 10 raised to 3 Newton meter. So those who have calculated, you send your answers in the chat box. So Tmin is equal to 35.80 into 10 raised to 6 into 10 raised to 6 Newton mm. Those who have calculated, send your answers in the chat box. 35.80 into 10 raised to 3. This is the first answer in Newton meter. And I have told in the power formula, if you will keep the power in the watt, you will get the first answer in the Newton meter. Don't forget to make or to convert it in Newton mm by multiply by 10 raised to 3. So it will become 10 raised to 6. 10 raised to 3 into 10 raised to 3, it becomes 10 raised to 6. So this is the T mean value. This is the T mean value. Then you are having the relation. T max is equal to 1.2 into 35.80 into 10 raised to 6. What is the T max value?
42.97
42.96
raised to 3.
into 10 raised to 6.
Into 10 raised to 6, not 3. तुम्ही जर वरचीच व्हॅल्यू 10 raised to 3 मध्ये मल्टिप्लाय केलं नसेल आणि तीच व्हॅल्यू अशी खाली घेतली आणि जर 1.2 जर मल्टिप्लाय केलं तर तुमची ती व्हॅल्यू 10 raised to 3 मध्येच राहणार आहे, बट इट इज नॉट कन्वर्टेड इन न्यूटन mm. This is the standard process you have to keep in mind. Sometimes we are able to solve the problem very easily, but by mistakes we are not converting the parameters wherever it is required, and your all the calculations will be wrong. So once you are calculating the terms, check it properly whether we can take this term as it is for your calculation or not. So this is just 42.96. Only you have to multiply by 1 by 2 for the T mean value, and you will get the T max value, and that T max value we have to consider for the calculation. 42.96 into 10 raised to 6 Newton mm. Okay, so now up to this, the procedure is same for all the types of problems. Now further, first of all, based on, put the heading, based on shear stress. Based on shear stress. So take our formula, T max upon J is equal to tau upon R. Okay, now T max value 42.96 into 10 raised to 6 divided by J. This is the hollow shaft, therefore pi by 32 in square bracket do raised to 4 minus di raised to 4 square bracket complete is equal to tau. The tau value is given 60 divided by RO. This is the RO, means DO divided by 2, because this is the hollow shaft. Now next step, 42.96 into 10 raised to 6 into 32. I will take at the numerator side, divided by this pi as it is into, see, square bracket of do raised to 4 minus di ची व्हॅल्यू आपल्याला माहित आहे 0.375 into do small bracket complete raised to 4 square bracket complete is equal to 60. This 2 is present at the denominator side. I will take to the upper side into 2 divided by q. Okay, now 42.96 into 10 raised to 6 into 32 divided by pi into the square bracket as it is do raised to 4 minus, tell me, 0.375 raised to 4 ह्या टोटल ब्रॅकेटचा आपल्याला raised to 4 करायचा आहे. What will be the answer? 0.37 raised to 75 raised to 4 किती ते answer?
0.0197.
0.0197 into d raised to 4 as it is, square bracket complete, is equal to this 60 into 2 means it becomes 120 divided by du. Okay, then next step, 42.96 into 10 raised to 6 into 32 divided by pi as it is into, now see at the denominator side bracket मध्ये काय आहे, d o raised to 4 minus 0.0197 into d o raised to 4 म्हणजे d o raised to 4 and d o raised to 4, these are the common terms. I will take outside the bracket d o raised to 4 in bracket 1 minus 0.0197 bracket complete is equal to 120 divided by d o raised to 4. Okay, so these are the next step. Now what I have to do, we have to take the d o raised to term. D o raised to term is present at the left side also, d o raised to 4 term is present at the right side also, but for final calculation you have to take at one side. मग काय करतो बघा, d o raised to 4 which is present at the left side, d o raised to 4, sorry here only d o,
DO
at the right side only do term is there. Okay, so do term is present at the left side also it is present at the right side also. Okay, but this is the unknown parameter, we have to take at one side. So what I will do, whatever the do raised to 4 which is present at the left side and it is present at the denominator, बघा हे do raised to 4 जी टर्म आहे ही लेफ्ट साइडला आहे आणि डिनॉमिनेटरला आहे, ती जर मी राईट साइडला घेतली इकडच्या बाजूला तर ती कुठे जाणार आहे, वरच्या बाजूला न्यूमरेटरला जाणार आहे. ठीक आहे, अँड दिस 120 इट इज प्रेझेंट ऍट द राईट साइड आणि असताना ते कुठं आहे, न्यूमरेटरला आहे, ते जर मी लेफ्ट साइडला घेतलं तर ते कुठं जाणार आहे, तुमचं डिनॉमिनेटरला जाणार आहे. तर काय करणार बघा, दिस 42.96 into 10 raised to 6 into 32 divided by this pi as it is bracket मधलं 1 minus 0.0197 as it is into 120 तिकडे झालेलं is equal to do raised to 4 divided by do. Okay, then what is the term which are present at the left side? Do this whole calculation, 42.96 into 10 raised to 6 into 32 divided by pi in bracket 1 minus 0.0197 into 120. What is the total calculation of this term?
3.71 into 10 raised to 6.
3.71 into 10 raised to 6 is equal to, now at the right side वरच्या बाजूला do raised to 4 आहे, खालच्या बाजूला do आहे, 1 do from the numerator, denominator it will get cancel, you will get the term do cube and त्याचं जर क्यूब रूट जर तुम्ही घेतलं तर do is equal to
154.80.
154.80, just I will check, 154.80. Yeah. So those who have calculated, please send your answers in the chat box. Variations in the answers will be accepted, but it should be 154 point something. Those who have got those answers that you have to send 154.80 or 154.66, 154.85, like that. Some variations you will get, no problem. It depends upon the number of digits or whatever the another procedure we are following. Accordingly, your answers will be variable, but it should not be 156 and 152 like that. 154 point something mm. So that value you will get by taking the cube root. 3.71 into 10 raised to 6. This is the total term which are present at the left side. And that terms जर आपण cube root घेतलं तर you will get the 154.80 mm. This is the DO value. We have to calculate the DI also. So 0.375 into DO is equal to 0.375 into 155.80 is equal to, what is the DI value?
58.05.
58.05. Yeah. Check this answer also. DI is equal to 58.05. This value is obtained from the shear stress. This is 92.97. This is wrong. Please do the KISS calculation once again. DI calculation. do this calculation once again. Yes, 58.05. These are the two diameters, external diameter and internal diameter we have calculated. From the shear stress concept, and based on this, whatever the previous three problems fall, it is up to this only. 58.05 or 58.06. This is the internal diameter and the external diameter by using the shear stress. Everyone has to send your answers in the chat box. Still only few students are sending. I am checking the answers of all the students in the chat box. So this is the based on shear stress. Same process we have to follow for the remaining calculation. Only formula is different. Same process we have to follow for remaining concept. Only formula is different. So 58.05 and or I will consider 58 mm is the internal diameter and 154 is the external diameter based on the shear stress concept. Now next, based on like this also you have to write in your notebook, based on angle of twist, based on angle of twist. Okay, so we are having the formula. What is the formula? T max upon J is equal to
G theta
J
by L.
theta,
J
yes.
theta by L. एकच टॉर्शन फॉर्म्युला आपण फक्त दोन कंडिशन मध्ये काय केलंय डिवाइड केलंय. Okay, so this is the second formula based on the angle of twist. So put the value once again. See 42.96 we have calculated. Same we have to use because left side term is common for all. 10 raised to 6 divided by pi by 32 in square bracket do raised to 4 minus d raised to 4 is equal to G value 0.85 into 10 raised to 5 into theta value we have converted. What is that value? 0.0349 divided by length 4000. Okay, then next 42.96 into 10 raised to 6 into 32. Okay, divided by this pi into again same process we have to put, that is d raised to 4 as it is minus 0.375 into do small bracket complete raised to 4 is equal to. Now tell me this answer which are present at the right side. G theta by L, what is the total value? कारण इकडच्या बाजूला कुठेच अननोन पॅरामीटर नाहीये. What is this total answer? G theta by L.
741.62 into 10 raised to minus 3.
0 point, sorry,
741.62.
this is 0.85 into 10 raised to 5, not 10 raised to 6.
Yes.
0.741.
0.741.
1.62 into 10 raised to minus 3.
Again it is coming 10 raised to minus 3
No, sir.
or only
this one.
0.7416.
Yes, sir. Yes, sir.
Please check it once again. 0.7416. I think 10 raised to minus 3, that term is not coming. Check it once again. 0.7416. This is the final answer.
0.
Correct? I think that due to the 10 raised to 6, that answer is different. Make it 0.85 into 10 raised to 5. 0.7416. This is the final answer. The term which are present at the right side. Getting? आलंय का?
Yes, sir.
Yes, sir.
Then next 42.96 into 10 raised to 6 into 32, okay, divided by this pi as it is, okay. परत सेम do raised to 4 minus 0.375 raised to 4 याचं जर आपण केलं तर 0.0197 into do raised to 4 is equal to 0.7416. Okay, same whatever we have followed for the previous concept. Then 42.96 into 10 raised to 6 into 32 divided by pi into d raised to 4 ब्रॅकेटच्या बाहेर घ्या राहिलं काय 1 minus 0.0197 is equal to 0.7416. Then next d raised to 4 it is present at the left side at the denominator. ही जर पूर्ण टर्म जर मी इकडे घेतली तर इकडे मल्टिप्लाय होणार आहे आणि 0.7416 हे असताना राईट साइडला आहे ते जर मी इकडच्या बाजूला घेतलं तर ते कुठे जाणार आहे डिवाइडला जाणार आहे त्यामुळे काय होणार आहे बघा टर्म 42.96 into 10 raised to 6 into 32 divided by pi into ब्रॅकेट मध्ये 1 minus 0.0197 bracket complete into 0.7416 is equal to do raised to 4. What is this total calculation which are present at the left side?
601.91 into 10 raised to 6.
601
.91
91 into
into 10 raised to 6.
is equal to do raised to 4. So please check your calculation also by following the same procedure whatever I have told and taking the square root 2 times by taking square root 2 times because d raised to 4 term is there or आलेल्या आन्सरला जर आपण raised to 1 by 4 केलं that also correct step, but if you take the raised to 4 or by taking the square root 2 times you will get the do value. What is the answer?
156.63.
156.63 mm. So this is the external diameter by using the angle of twist. Check your answers. Those who have calculated, send your answers in the chat box. 156.63 or 156.59, that variation is accepted. In the previous concept you will get the do value in the form of cube root कारण do term ही दोन्ही बाजूला present होती, but here you will get the do terms in the form of do raised to 4 because it is present at only one side, and by taking the square root 2 times you will get the answer 156.63 and you are having di is equal to 0.375 into 156.63 is equal to what is the di value?
58.73.
58.73. Yeah. This is the di value. 58.73 or 58.72 or 58 point some another digits as per your calculation. Please check your answers, do the calculations and send me your answers in the chat box, so we'll verify the answers accordingly. 156 and 58. Now compare your both values. Those who have calculated, please compare the both values. Compare the do and di value from the angle of twist concept and from the shear stress concept. Your values are different as per your calculation, but I want only one answer. Which values are maximum? Either values are obtained from angle of twist or values obtained from the shear stress? Which values are maximum?
Angle of twist.
Angle of twist.
Okay, angle of twist. So in such conditions, you are having the diameters. You got the diameters by using the shear stress value also. You got the diameter by using the angle of twist also. But which diameter we have to consider for the calculation? So for that purpose, the suitable value of the diameter is always maximum value of the diameter. Okay. So this is your final answer. So after calculating this, you have to write one statement. After this calculation, you have to write one statement. I will dictate that statement. You write in your notebook. Write down the suitable value of diameter is the suitable value of diameter is the suitable value of diameter is always maximum value obtained. The suitable value of diameter is always maximum value obtained. Maximum value obtained, which we have to consider maximum value obtained, which we have to consider for designing the shaft, which we have to consider for designing the shaft, which we have to consider for designing the shaft, full stop. Therefore DO is equal to, once again, DO is equal to 156.63, whatever answer you got by using the angle of twist, that you have to write the DO value, and DI is equal to 58.73 or 58.72, 58.74, whatever you have obtained. But whatever the values obtained from the angle of twist calculation, that diameter values are maximum as compared to the shear stress value. त्यामुळं angle of twist चा वापर करून जे काही diameter value आलेले आहेत, that we are considering for the designing of the shaft. So here you got the two values, therefore we made the comparison. But whatever the previous three problems we have solved, in that they have given only shear stress, and that is your final answer. Whatever the diameters we have calculated by using the shear stress concept, that is your final answer, because there is no any comparison. But here we have to make the comparison, and after comparing, you have to check which values are maximum, and that maximum values we have to consider for the designing of the shaft. So this statement, and after this statement, again this maximum two values you have to write in your notebook. Yes, Samarth, your mic is on.
Sir.
How to do the comparison, how to check the values? Please check here. Only you have to go the comparison of DO values and comparison of DI values, and then we have to write the final answer by writing this particular statement, whatever I have dictated now. Suitable value of diameter is always maximum value obtained, and that value we have to consider for designing the shaft. Okay, so this is the problem based on the shear stress concept and the angle of twist concept. If both the concepts are mentioned in the statement, two formulas we are having: Tmax value, Tmax value we have to consider same for both the concepts, because T upon J, this is the same value. Okay, everyone have understood the procedure?
Yes, sir.
What about others? Everyone have understood the procedure, how to calculate the diameter if the shear stress and the theta angle is mentioned in the statement. Only formulas are different, procedure is same. Okay, based on this, one more problem we will take. Based on this angle of twist and the shear stress concept, one more problem we will take. Now I will explain the problem. I will explain the statement simultaneously. You solve it, and now you have to tell me the answers in the chat box. Okay. So now this is the problem in front of you. See, I will read the statement. I am also solving the simultaneously with you, but you follow the procedure of the previous problem and tell me the answers accordingly. See, a hollow shaft of diameter ratio 3 by 8 is required to transmit 588 kilowatt at 110 rpm. 110. This is not 770. Transmit the power of 588 kilowatt at 110 rpm, full stop. The maximum torque is 20% greater than mean torque. Shear stress is not to exceed 60 Newton per mm square and twist in a length of 3 meter. Twist in a length of 3 meter and not to exceed 1.4 degree. But just a maximum shear stress is not to exceed 60 Newton per mm square. That means this is the maximum shear stress value. Similarly, if there is a possibility of twisting and that twisting is also not to exceed 1.2 degree. 1.2 degree पर्यंत that shaft can easily sustain. But if it is exceeds more than 1.4 degree, याच्यापेक्षा जर जास्त जर तुमचं twisting झाला असेल, there is a possibility of failure. Okay, therefore the twisting should not to exceed 1.4 degree, full stop. Calculate internal and external diameter of shaft will satisfy the conditions. Take capital G is equal to 84 giganewton per meter square. 84 giganewton per meter square. Same statement like previous problem, and you have to find out the internal diameters and external diameters. So first of all, write down the given parameters along with me. See, di upon do is equal to 3 by 8. Therefore, di is equal to same 0.375 into do. Then power is given 588 kilowatt. So 588 into 10 raised to 3 watt. N is given 110 rpm. Then Tmax is equal to 100 plus 20 divided by 100 into Tmin is equal to 1.2 into Tmin. Okay. Then shear stress tau is equal to 60 Newton per mm square. Length of shaft is 3 meter. L is equal to 3 meter is equal to 3000 mm. Theta is equal to 1.4 degree is equal to 1.4 into pi by 180 is equal to converted to radian. G is equal to 84 giganewton per meter square, means it is also gigapascal. Therefore, G is equal to 84 into 10 raised to 3 Newton per mm square, and we have to calculate DO and we have to calculate DI. What is the theta value in radian? 1.4 into pi by 180.
0.02443.
0.024, sorry, 0.0244 radian. Take this value, theta value we have to convert in radian, that is multiply by pi by 180, that is 0.0244 radian. Other values are also given, we have converted. G value is given in giganewton per meter square, means it is also gigapascal, because giganewton multiply by 10 raised to 9, then meter to mm, multiply by 10 raised to 3. By cancelling the terms, you will get the 10 raised to 3 only. So these are the given parameters. Now our first step is we have to calculate the T max value separately and T min value separately because their relations are given. So first value we have to take as a T min and we have to calculate from power P is equal to 2 pi n T min divided by 60. So put the values and tell me the value of T min. Put the power formula, put the power value n 110, you will get the T min value in the form of Newton meter. What the T min value?
51.04 into 10 raised to 3.
Okay, T min. Those who have calculated, send your answers in the chat box. 51.04 into 10 raised to 3 Newton meter. Here I will write 51.04 into 10 raised to 3. This is in Newton meter. Again multiply by 10 raised to 3. That is, it becomes 10 raised to 6 Newton mm. Do your calculations and send me your answers in the chat box. Power formula P is equal to 2 pi nt divided by 60. 51.04 into 10 raised to 3. This is the first answer in Newton meter only. But we want that value in Newton mm. So again multiply by 10 raised to 3 and it becomes 10 raised to 6. .04 into 10 raised to 6 Newton mm. Then T max is equal to 1.2 into 51.04 into 10 raised to 6. What is the T max value? Multiply by 1.2.
61.24 into 10 raised to 6.
61.24 into 10 raised to 6 Newton mm. 61.24 into 10 raised to 6 Newton mm. This is the T max value. Everyone has to calculate and send your answers in the chat box. Again, still few students, and that are the girl students are sending. What about others? Otherwise, I have to ask personal to each and every student. Whatever you are calculating, send your answers in the chat box. First T min value in Newton meter, then you have to multiply by 10 raised to 3, it becomes 10 raised to 6. And as per the relation between T max and T min, you will get the T max value as 61.24 into 10 raised to 6 Newton mm. So those who have calculated this value, go for your further calculation also. Based on shear stress, put the formula, follow the procedure of previous problem and solve it, and accordingly send me the answers of the diameters. Instead of giving the homeworks, we are solving the problem here only. Okay, 61.24 into 10 raised to 6. Now the first, based on shear stress, T max upon J is equal to tau upon Rho, because hollow shaft is there. Now put the value T max 61.24 into 10 raised to 6 divided by 5 by 32 d raised to 4 minus d raised to 4 is equal to tau 60 divided by DO divided by 2. This is the next step. Now we have to put the value of di because the relation is given as a 3 by 8. Relation is given as a 3 by 8 and that we have converted in 0.375. So 61.24 into 10 raised to 6 into 32. I will take at the top side divided by pi into DO raised to 4 minus 0.375 DO raised to 4 square bracket complete 60 into 2 divided by DO. Same value you will get 61.24 into 10 raised to 6 into 32 divided by pi into त्याच्यामध्ये आय विल अप्लाय सम शॉर्टकट दॅट इज DO raised to 4 जर तुम्ही स्क्वेअर ब्रॅकेट मधून बाहेर जर घेतलं तर तुमचं ब्रॅकेट मध्ये 0.0197 is equal to 120 divided by DO and then you will get the answer in the form of DO cube and you have to tell me the DO value directly. That is 61.24 into 10 raised to 6 into 32 divided by pi into 120 into 1 minus 0.0197 into DO cube या फॉर्म मध्ये तुम्हाला इक्वेशन मिळेल कारण DO raised to 4 जर इकडच्या बाजूला घेतलं तर it will get at the numerator side मग DO raised to 4 divided by DO you will get the DO cube and by taking the cube root you will get the DO answer. Tell me the answer.
174.38.
Correct. 174.38 mm. This is the correct answer. And what is the DI? 0.375 into 174.38. Therefore, DI is equal to how much?
65.402.
65.39.
65.39 or 40. This is based on shear stress. Those who have calculated, send me answers in the chat box. Yes, 174.38 and 65.40, 65.39. That is correct. 174.38 answers. All answers are near to the our required value. 174.38 and 65.40 or 65.39 mm. This is the external diameter and the internal diameter. So same procedure we have followed. And that diameter ratio is also same 3 by 8 and 3 by 8. So here I have skipped some steps because that calculation is somewhat same like previous one, but we have to follow the same procedure for remaining problems. 174.28. Yes, it is also accepted, no problem. Depends on the digits you are considering for the calculation. 174.28 mm and 65.40 mm. This is the internal diameter. Everyone has to solve this and you have to send answers in the chat box. Those who have solved for the shear stress concept, they can go further and try to solve for the angle of twist also and send me the answers accordingly. I will also check the answers. So those who have calculated this 174.28, 38, that all the answers are accepted. Internal diameter answers are also accepted. Now we'll move to the next. Based on angle of twist. Based on angle of twist. So we are having the formula T max upon J is equal to G theta by L. Put the value once again 61.24 into 10 raised to 6 divided by pi by 32 in bracket DO raised to 4 minus DI raised to 4 is equal to G 84 into 10 raised to 3 into theta 0.0244 divided by length 3000. Your next step 61.24 into 10 raised to 6 into 32 divided by pi in square bracket मध्ये do raised to 4 minus 0.375 do bracket raised to 4 square bracket complete. What will be the term which are present at the right side? G theta by L ची व्हॅल्यू किती आहे ते सांगा.
0.6832.
0.6832 correct. 0.6832. Simplify this value because don't take this term right side left side कारण तिकडच्या बाजूला कुठलाच अननोन पॅरामीटर नाही आपला g theta by L ला कुठलाच अननोन पॅरामीटर प्रेझेंट नाही. That's why do that calculation immediately and write that value as it is. Okay, then further steps I will write. See, 61.24 into 10 raised to 6 into 32 परत divided by pi term. ह्याच्यामध्ये जर तुम्ही d raised to 4 जर ब्रॅकेटच्या बाहेर घेतला तर ब्रॅकेटमध्ये राहते तुम्हाला 1.0.0197 is equal to 0.6832 आणि तुम्ही d raised to 4 ह्याच्यामध्ये जर टर्म लिहिली तर you will get the answer 61.24 into 10 raised to 6 into 32 divided by this pi value as it is into ब्रॅकेट मध्ये 1 minus 0.0197 इकडची टर्म जर खाली घेतली तर इट विल गेट डिवाइड 0.6832 आणि हे d raised to 4 जर तुम्ही राईट साइडला घेतलं तर इकडे काय होणार आहे ते मल्टिप्लाय होणार म्हणजे d raised to 4. व्हॉट इज दिस आन्सर? d raised to 4 काय ते व्हॅल्यू सांगा लेफ्ट साइडची.
931.38 into 10 raised to 6.
931.38 into 10 raised to 6 is equal to d raised to 4. Take square root 2 times. You will get the do value.
174.9.
174.69.
174.69 mm. Very small change is there from this value and the previous value. In the previous also 174 point something and here also 174 point something. That means only small change we have obtained. पण त्याच्या अगोदरच्या प्रॉब्लेम मध्ये जर बघितलं तर at one side you will get 156, at one side you will get 154. So that 2 mm variations is there. So 174.69 mm. This is the external diameter by using the angle of twist. And then DI 0.375 into 174.69.
65.50.
65.50 mm.
65.52.
65.52. Okay, no problem. 65.50 or 65.52 mm. No problem. So whatever answer you got, you send in the chat box. 65.50 or 65.52 mm or any variations, whatever you got. Do the calculation. Same procedure we have to follow what we have followed for the previous problem, and then we have to go for the calculation. In shear stress concept, you got the do value in the form of cube root because do terms are present at the left side and at the right side, and by cancelling the terms you will get the answer in the form of do cube. There's a cube root घेऊन तुम्हाला do ची value काढावी लागते. Then in the angle of twist you will get the value in the form of do raised to 4 because do term is present at only one side, because g theta by L all the parameters are given, and then by taking the square root 2 times you will get the do value. Now if you compare both the values, again what will be the maximum based on angle of twist or based on shear stress?
Angle of twist.
Angle of twist. If you check 174.38 based on shear stress and 174.69 based on the angle of twist. Therefore, do is maximum from the angle of twist. Then di based on shear stress 65.39, and based on the angle of twist 65.50 or 65.52, again it is maximum. Therefore, you have to write down the statement once again. The maximum value of diameter is always, or the suitable value of diameter is always maximum values obtained. The suitable value of diameter is always maximum value obtained, and based on this, the design of the shaft will be taking place. Therefore, once again, DO is equal to 174.69 and DI is equal to 65.50 mm. So this is the final answer. Don't forget to write down the final answer also. परत तेच आन्सर तुम्हाला लिहावं लागणार आहे by writing that statement. The suitable value of diameter is always maximum value obtained, which we have to consider for designing the shaft. And therefore, DO is equal to 174.69 and DI is equal to 65.50 or 65.52 mm. Yes, everyone have calculated? I'm not getting the replies from the A division students except girl students. What about others? They are attending for just attendance purpose. I'm going to check the notebooks at the end as a part of submission. If it is not there, accordingly marks will be given. So you have to do this calculation at your home in your notebook. You have to do the calculation. You have to send the answers in the chat box. Okay, I hope everyone has calculated. Okay, have understood the procedure, how to follow the procedure for both the concepts and how to calculate and how to go for the comparison. Yes, everything is the value of angle of twist is greater. Sometimes it is greater, maximum times. If you do the calculations and based on the angle of twist. Now here the angle of twist is 1.4 degree. For the previous problem, angle of twist value is 2 degree. There is a variation in the diameters. And now if you see the both the problems, दोन्ही प्रॉब्लेम मध्ये अँगल ऑफ ट्विस्टच्या व्हॅल्यूज मॅक्सिमम आलेल्या आहेत. If your angle of twist is maximum, then based on that particular theta value, your answers will be variable. So for that purpose, your comparison is required. आताच्या दोन प्रॉब्लेम मध्ये जरी अँगल ऑफ ट्विस्टच्या व्हॅल्यू नुसार दोन्ही डायमीटर हे मॅक्सिमम आहेत, but sometimes based on the variation of the theta value, sometimes based on the shear stress also you will get the values maximum. So based on that, we cannot say that the angle of twist values are only maximum. For that purpose, we have to do the comparison, and from the comparison we have to final the diameters. Okay, so comparison is very important. So up to this, we have finished this particular type number 2 also, that is design of the shaft. So we have designed the shaft based on the shear stress concept and based on the angle of twist concept. So in this particular type number 2, we have to calculate only diameters. So for that purpose, we need to read the statement carefully. We have to check all the given parameters, and accordingly we have to select the condition, whether it is based on the shear stress or whether it is based on the angle of twist. And accordingly, we have to do the calculations. If only one condition is there, need not require to go for the comparison, because there is only one condition means only single diameters you will get. But if there is a two conditions, then we have to solve the problem by using the two conditions, and we have to select the diameters as a maximum values. Okay, if anybody is having any problem, you can ask. Everyone have understood this particular type number 2? If you have any questions, you can ask. Everyone has understood? Type number 2, it is very simple and straightforward.
Yes, sir.
Okay. What about others? Everyone have understood? If you understood, then and then only we move further. If you have not understood, you can ask the questions, any query, any calculation part. Okay. Only you have to keep the torsion formula in your mind, and that formula we have to divide in the two different concepts based on the shear stress and based on the angle of twist. Okay, so I hope everyone has understood. Still, if you have any problem while studying at your home, you can ask me anytime. I will explain again and again. Okay, and now the type number 3. It is very also simple. So put the heading type number 3. This will be the last type of this particular chapter, type number 3. See, what is the type number 3? Put the heading composite shaft. Composite shaft or shaft connected in series. Composite shaft or shaft connected in series. So what is meant by the composite shaft? Already we have discussed what is meant by the composite material. If more than two materials are combined together, if more than one material, एकापेक्षा जास्त मटेरियल जर एकमेकाच्या कॉन्टॅक्ट मध्ये आलेले असतील तर that structure we can call it as a composite structure. And based on that, in the chapter number 1 we have solved the problems. Based on that, we have solved the problems in the chapter number 1, that is composite structure, composite bars. Similarly, the composite shafts are also there. What is the definition of composite shaft? The shaft of different materials are connected to each other. That shaft is called as a composite shaft. If one shaft is there and it is made by the steel, if one shaft is there and it is made by the steel, it is called as only steel. But if that steel material or if that steel shaft is connected to the another shaft having the different material, if the steel shaft is connected to the another shaft and that another shaft is having the different material, for example brass, then that shaft is not called as a steel brass shaft, or it is not called as a brass steel shaft. Simply it is called as a composite shaft. Therefore the simple definition I have written here: the shaft of different materials are connected to the each other. एकमेकाला जर अशा वेगवेगळ्या मटेरियलचे जर शाफ्ट एकमेकाला कनेक्ट केलेले असतील किंवा ते एकमेकाच्या कॉन्टॅक्ट मध्ये असतील तर तो टोटल स्ट्रक्चरला आपण काय म्हणू शकतो? कंपोजिट शाफ्ट म्हणतो. मग त्यालाच आपण काय म्हणलंय? शाफ्ट कनेक्टेड इन सिरीज. मग शाफ्ट सिरीज मध्ये कनेक्ट केले आपण असं कधी म्हणू शकतो? तर त्याच्यासाठी figure is given in front of you. So what is that particular figure? See, this is the shaft number 1. This is the shaft number 1, which one end is fixed. This is the shaft number 1 having diameter D1, length L1, cross sectional area A1. Okay, this is the shaft number 2 having diameter D2, length L2. Then shaft number 3 is also connected to each other having diameter D3, length L3. Okay, the first shaft is having the material Al, means aluminum. Second shaft is having the material steel. Third shaft is having the material brass. That means the aluminum shaft is connected to the steel shaft is connected to the brass. All these particular 3 shafts are connected to the each other. Therefore this total structure is called as a composite shaft. Okay, the aluminum is connected to the steel is connected to the brass. Therefore this total structure is called as a composite shaft. And in addition to that, these shafts are connected in series. How we can say that the shafts are connected in series? So the definition is given at the bottom side. If the shaft of different materials are connected to each other along the length, this word is very important. The shaft of different materials are connected to each other along the length, that is called as a shafts in series. So if you see the shaft number 1, which is made by the aluminum material having length L, त्याच्या समोर लगेच steel shaft. It is connected in series because this is the length L1, this is the length L2, this is the length L3, and length is present in the horizontal direction or it is present in X direction. Therefore aluminum shaft, steel shaft and the brass shafts are connected along the length. म्हणजे जिथं तुमचा अल्युमिनियम शाफ्ट संपतोय तिथंच लगे तुमचा स्टील शाफ्ट कनेक्ट झालेला आहे. जिथं तुमचा स्टील शाफ्ट संपतोय तिथंच लगे तुमचा हा ब्रासचा शाफ्ट कनेक्ट झालेला आहे. मीन्स ऑल द थ्री शाफ्ट्स आर कनेक्टेड टू द each other along the length, and this particular structure is called as a composite shaft and it is connected in series. Please keep in mind, when we can say that shafts are connected in series, the shaft of different materials are connected to the each other along the length. That structure is called as a shaft connected in series. Means this is the axis of all the shafts. This is the axis of all the shafts, and the axis of steel shaft is perpendicular to the axis of aluminum. Axis of brass shaft is perpendicular to the axis of the steel shaft. That means all the axes are perpendicular to each other. If the shafts are connected in series, their axes are perpendicular to each other, or if all the shafts are connected in along the length, then that structure is called as a shaft connected in series. If such conditions are given and their one end is fixed and at another end the T amount of torque is applied, whatever the free end is present at the brass material, जिथं ब्रासचा शाफ्ट आहे तिकडची साइड तुमची काय फ्री आहे, आणि whatever it is fixed at left side, it is totally fixed condition, but at free end the T amount of torque is applied, and due to this particular T amount of torque the shaft is under twisting. The shaft is under twisting, and according to that how much amount of twisting is taking place, that theta value we have to calculate. And for that purpose here we have to consider in one condition, that is same figure I have considered, that is the total composite shaft is fixed at one side, another end is free, that is right side. This is the right side and this is the left side. The left side is fixed, right side is free, and at the right side the T amount of torque is applied, and due to this particular T amount of torque, here some amount of twisting is taking place, and that twisting is represented by theta, and that theta value we have to calculate. Then, and if the shafts are connected in series, if shafts are in series, then condition number one, total torque capital T is equal to T1 is equal to T2 is equal to T3. जरी हा टॉर्क फ्री एंडला अप्लाय झालेला असेल आणि तो ब्रासवर अप्लाय झालेला असेल, but here we have to consider one condition, that is total torque is equal to T1 is equal to T2 is equal to T3, because shaft number 1 and 2 are connected to each other, shaft number 2 and 3 they are connected to each other. त्यामुळे जरी हा टॉर्क फ्री एंडला अप्लाय केलेला असेल तरी पण तीच टॉर्क व्हॅल्यू तुम्हाला शाफ्ट 1 साठी पण कन्सिडर करायची आहे, शाफ्ट 2 साठी पण कन्सिडर करायची आहे आणि शाफ्ट 3 साठी पण कन्सिडर करायची. गेटिंग? जर ह्या ठिकाणी जर एक्सटर्नल फोर्स असा पी जर अप्लाय झाला असता टेन्साइल मध्ये, तर तोच पी फोर्स आपण पहिल्या सेक्शन साठी कन्सिडर केला असता, दुसऱ्या सेक्शन साठी कन्सिडर केला असता आणि तिसऱ्या सेक्शन साठी कन्सिडर केला असता. Similarly, whatever the torque is applied at the free end, one end is fixed, the same torque value we are considering for the shaft number 1, shaft number 2 and shaft number 3, that is capital T is equal to T1 is equal to T2 is equal to T3. And then second condition is total angle of twist theta is equal to, can you tell me this formula? Total angle of twist theta is equal to total angle of twist. Now please tell me, if the T amount of torque is applied at the free end, the T amount of torque is applied at the free end. Angle of twist in the shaft number 1, 2, 3, whether it is same or different. Due to the T amount of torque applied at the free end, whatever the twisting is taking place, whether it is same or different in each shaft. One end is fixed, another end
Different.
different. If you see, initially the T amount of torque is applied on the brass shaft and it is free end. T amount of torque is applied at the free end, means at the brass shaft, but this brass is connected to the steel is connected to the aluminum. So maximum twisting is taking place at the free end. त्याच्यापेक्षा थोडं सेंटरला आणि त्याच्यापेक्षा कमी फिक्स्ड आहे, कारण हा फिक्स्ड साइड आहे म्हणजे काय करते, इट इज अपोजिंग टू द ट्विस्टिंग मूवमेंट. फिक्स्ड साइड काय करते, इट इज अपोजिंग टू द ट्विस्टिंग मूवमेंट. देयरफॉर मिनिमम अमाउंट ऑफ ट्विस्टिंग इज टेकिंग प्लेस इन द अल्युमिनियम पेक्षा थोडं जास्त स्टील मध्ये, आणि स्टील पेक्षा जास्तीत जास्त ट्विस्टिंग इट इज टेकिंग प्लेस ऍट द ब्रास मटेरियल. Therefore, the twisting is always maximum at the free end and it is less at the center point and it is very less at the fixed side. Therefore, as the twisting is different in the shafts are in connected in series, therefore total angle of twist it will be different in each and every shaft. Therefore, theta is equal to theta 1 plus theta 2 plus theta. Then what is the value of theta? Therefore, we are having the formula T upon J is equal to G theta by L. ह्या फॉर्म्युलाचा उपयोग करून आपल्याला थीटाची व्हॅल्यू डिफाइन करावी लागेल. म्हणजे थीटा व्हॅल्यू काय येणार बघा, हा थीटा जर आपण आहे असा ठेवला तर T into L divided by G into G. So this is the theta formula. Getting? We are having the torsion formula T upon J is equal to G theta by L. I have written the equation in the form of theta. हे L कुठे गेलं, वरच्या बाजूला गेलं, म्हणजे T into L. हे G कुठे आलं, खालच्या बाजूला आलं. Therefore T into L divided by G into J, म्हणजेच T into L divided by G into J of section number 1 plus T into L divided by G into J of section number 2 plus T into L divided by G into J of section number 3. जसा आपण डिफॉर्मेशनचा फॉर्म्युला लिहितो, डेल्टा L is equal to डेल्टा L1 plus डेल्टा L2 plus डेल्टा L3, that is PL upon AE of section number 1 plus PL upon AE of section number 2 plus PL upon AE of section number 3. जसा हा डेल्टा L हा डिफॉर्मेशन इंडिकेट करतो, तसं ह्या रोटेटिंग शाफ्ट मध्ये हा थीटा पण एक प्रकारचं डिफॉर्मेशन इंडिकेट करतोय. बट दिस डेल्टा L इज द linear deformation and this theta is the angular deformation, because shaft is the rotating element and जो तो रोटेट होत असेल आणि ते रोटेट होताना जे काही डिफॉर्मेशन होतं, that deformation it is in angular form. Therefore that deformation is called as a angular deformation. जसं एखाद्या बॉडीवर एक्सटर्नल फोर्स अप्लाय होतो आणि त्या एक्सटर्नल फोर्स मुळे त्याचं जे काही डिफॉर्मेशन आपण फाइंड आउट करतो, इट इज फाइंडिंग बाय डेल्टा एल. दॅट इज डेल्टा एल इज इक्वल टू डेल्टा L1 प्लस डेल्टा L2 प्लस डेल्टा L3. आणि त्याच्यामध्ये कॅपिटल P इम्पॉर्टंट रोल प्ले करतोय. तसंच in case of a rotating shaft, as it is subjected to the angular deformation and that angular deformation is represented by theta, therefore theta is equal to theta 1 plus theta 2 plus theta 3. And in this calculation this capital T plays very important role. जसं डेल्टा एल च्या फॉर्म्युलेमध्ये PL upon AE ह्या फॉर्म्युलेमध्ये कॅपिटल P इम्पॉर्टंट रोल प्ले करतोय, तसंच ह्या थीटाच्या फॉर्म्युलेमध्ये TL into G divided by J, त्याच्यामध्ये this capital T plays very important role. And if shafts are connected in a series, their total torque is equal to T1 is equal to T2 is equal to T3, but their angle of twist will be different because maximum twisting is taking place at the free end, त्याच्यापेक्षा कमी middle end, and त्याच्यापेक्षा कमी means negligible twisting will be taking place at the fixed side. Therefore, angle of twist will not remain constant if shafts are connected in series. Therefore, these two conditions are very important. So take this particular two conditions in your notebook. If shafts are connected in series, I will tell, if shafts are connected in series, if shafts are connected in series, below that total torque is equal to, below that total torque is equal to T1 is equal to T2 is equal to T3. T1 is equal to T2 is equal to T3. And second condition, total angle of twist in bracket theta is equal to total angle of twist in bracket theta is equal to theta 1 plus theta 2 plus theta 3. Theta 1 plus theta 2 plus theta 3. आणि त्याच्या खाली हे लिहा T upon J is equal to G theta by L. T upon J is equal to G theta by L and त्याच्या खाली theta is equal to TL into G divided by J. Write down this term first. Theta is equal to T into L divided by G into J. आणि मग त्याच्या खाली परत capital theta is equal to theta 1 plus theta 2 plus theta 3 which is equal to T into L divided by G into J of section number 1 plus T into L divided by G into J of section number 2 plus T into L divided by G into J of section number 3. म्हणजे सगळ्या थिटाची बेरीज म्हणजेच your total angle of twist and theta is called as a angular deformation. This is not a linear deformation. In chapter number 1, in chapter number 2, we have calculated delta L value so many times, and that delta L represents the linear deformation which is taking place due to the external load. पण आपण shaft वर external load apply करत नाही. The shaft is always subjected to the torsion, means it is subjected to the T amount of torque, and therefore capital T plays very important role in the deformation calculation or angular deformation calculation. Have taken this formula, condition number 1 and condition number 2 in your notebook. If the
Yes.
shafts are connected in series, this heading is very important. If shafts are connected in series, total torque is equal to T1 is equal to T2 is equal to T3. जसं आपण deformation मध्ये total P is equal to P1 is equal to P2 is equal to P3. Chapter 1 मध्ये problem number 2 bars of bearing cross section, जरी तो टेन्साइल असेल कॉम्प्रेसिव्ह असेल तर कॅपिटल P is equal to P1 P2 P3 सेम कन्सिडर करतो. तसंच ह्याच्यामध्ये कॅपिटल T is equal to T1 T2 T3. Take these two formulas in your notebook and we will solve one problem based on this and then we will stop. Very simple and the straightforward numerical is there. I'm taking this particular, this is not in your syllabus actually, but based on this concept, some MCQ questions are asking in the examination. Based on this, some MCQ questions are asking in the examination. Therefore, purposefully, I am taking this particular concept. Okay, I hope you have taken the list of the formulas in your notebook. We will solve one problem based on this and then we will stop. See, the statement is given. This is the statement. I will read the statement first. A compound shaft means composite shaft. A compound shaft is composed of 1 meter length of solid copper of 150 diameter. म्हणजे कंपाऊंड शाफ्ट मधला एक शाफ्ट कुठला आहे? सॉलिड कॉपर, म्हणजे कॉपर मटेरियलचा आहे, ज्याची लेंथ 1 मीटर आहे आणि डायमीटर 150 mm आहे. जॉईंट टू 2 मीटर लेंथ सॉलिड स्टील शाफ्ट, दोन्ही शाफ्ट हे सॉलिड आहेत. ओके, दिस कॉपर शाफ्ट इज जॉईंट टू 2 मीटर लेंथ ऑफ सॉलिड स्टील शाफ्ट. दुसऱ्या शाफ्टचं मटेरियल कुठलं आहे? स्टील आहे, त्याची लेंथ 2 मीटर दिलेला आहे and diameter 200 mm. Okay, a torque of 26 kilonewton meter is applied at the end of the shafts in opposite directions. आता इथं सांगताना मी shaft is fixed at one end and another end is free, त्याच्यामुळे त्याच्यामध्ये ट्विस्टिंग पॉसिबल आहे. जर इकडची साइड जर फिक्स्ड नसतीच असती तर we have to apply one more torque at the left side also, but it in opposite direction. जर शाफ्ट एका बाजूला फिक्स असेल आणि दुसऱ्या बाजूला फ्री असेल तर फ्री साइडलाच आपल्याला फक्त टॉर्क अप्लाय करावा लागतो. बट इफ द बोथ साइड्स आर फ्री, we have to apply one torque at the left side, we have to apply torque at the right side also, but both are in opposite direction and equal in magnitude.
Sir.
Okay.
Hello, sir.
Yes.
Sir is here, sir.
Hi, yes, sir.
Sir, there is one instruction from student dean, Professor Karam Patil, sir.
Okay. Okay, you can
Uh,
tell, sir. No problem.
they have arranged one anti-ragging session to the direct second year students. So I think you have combined both the division. You can continue your lecture on A division and tell to second year student only, direct second year student. I have sent one link of that program on their group. They can join the anti-ragging session right now.
Now, immediately.
Yes, sir, immediately. Only for direct second year student.
Okay.
Yes.
So, can I finish my this few points and then, or immediately it is required?
Actually, that program is started. So you continue for the division and tell to
Okay.
B division to join immediately. Already I
Okay.
have seen that link, session link on their WhatsApp group.
Okay. Okay. No problem. So, B division student, they can send your roll numbers in the chat box for your attendance, and we can leave and you can join the that session. So this part I will explain you again in the next lecture. Don't worry about this. I will explain this particular part once again. B division students only. You can send your roll number in the chat box and you can leave. And as per the instructions from the Asbesser, you can join that session. This part I will explain you again in the next lecture. Don't worry about this. A division students, you can be here as it is. We will finish this and we will stop. Okay, for the A division, I will continue. Okay, so the problem, the 26 kilonewton meter torque is applied at the end of the shaft in opposite direction. Means the shaft is not fixed at one side. It is free from the both sides. Therefore, they have given the condition like that 26 kilonewton torque is applied in opposite direction at the both sides. Find the maximum shear stress in the each material. Find the maximum shear stress in the each material and the total angle of twist in entire shaft. Whatever due to the T amount, this 26 kilonewton torque is applied. So some amount of twisting is taking place. That total angle of twist of entire shaft we have to calculate. Full stop. Take G for the copper 30 giganewton per meter square and G for steel material 85 giganewton per meter square. Okay, so these are the values. So first of all, we have to draw the figure. So see, two shafts are there which are connected to each other. पहिला shaft कुठला आहे? What is the first shaft? Copper. Length of copper is 1 meter and diameter 150. See, this is the copper shaft. Okay, their length is 1 meter and diameter 150 mm. Fine, and this is copper. Then next, another shaft of steel. Their length is 2 meter and their diameter is 200 mm. Okay, and it is subjected to the T amount of torque. So here this is the 26 kilonewton meter torque is applied and त्याच्या opposite side ला पण same value, that is 26 kilonewton meter torque, because here the shaft is not fixed at one side. If it is fixed at one side, we have to apply this 26 kilonewton meter force at only one side. दुसरी साइड फिक्स्ड आहे म्हणजे it is opposite twisting. What is our requirement? We have to apply the 26 kilonewton meter torque at both sides. At left side, if it is applied in the clockwise direction, then at right side we have to apply it. It is in anti-clockwise direction. If it is opposite, then and then only the shaft is under torsion or it is subjected to the some amount of twisting. Therefore, we have to apply the 26 kilonewton force at the both sides. So this is the figure which we have to draw. This is the figure which we have to draw from this particular statement, that is copper and the steel shaft both are connected to the each other and both are subjected to the 26 kilonewton torque at the free end, and it is applied in the opposite direction. Okay, so these are the figure given. Accordingly, we will write down all the given parameters. See, length of copper 1 meter is equal to 1000 mm. Then diameter of copper 150 mm. Length of steel 2 meter is equal to 2000 mm. Diameter of steel 200 mm. Then T, which is common, 26 kilonewton meter. We want this particular value Newton mm. So 26 into 10 raised to 3 kilonewton Newton मध्ये केलं, परत मीटर से mm मध्ये 10 raised to 3 means your torque value becomes 26 into 10 raised to 6 Newton. Someone mic is on. Just wait. They have joined this link. Yes. How the other students have joined this particular link? So Sagar Patil, can you unmute from your side, Sagar Patil?
Yes, yes,
You are from electrical department.
yes.
So how you have joined this link? Yes.
Yes, sir.
You have joined this lecture link.
From official WhatsApp. Electric.
You are attending that session or you are attending our lectures? Just wait. Okay, we will stop here. Some other students are joined by mistake here.